So, hello everyone. Hope you're doing well in these hard times and you're staying safe. And welcome to my talk, Let's Think Reactively. A little bit about myself before we start. My name is Lamis. I am based in Tunisia. I'm a senior software engineer, AGGE for Angular. I've been into Angular and the web for the past few years. I'm the founder of Angular Tunisia, and aside, I'm a speaker, mentor, and a content creator. And today we're going to speak about the reactive programming and how to set this reactive mindset. So the reactive programming is a programming paradigm like the functional programming, the object-oriented programming, and you can find many definitions in the web, but for me, it's programming with asynchronous data streams. It's enough with this definition. It's complete and exhaustive. Now, what's asynchronous and what's data streams? So asynchronous is, when we say asynchronous, is the opposite of synchronous, and it's something that doesn't happen at the same time, okay? For synchronous, it's happening at the same time. Well, this is the plain definition. But in programming, when we say synchronous, okay, so we are requesting something and we will not do anything until we get the response, okay? So, and when I get the response, I will do some process, and I will ask again for another information. I will send a request, and I will wait. I won't do anything until I get the response, and so on and so forth. This is for the synchronous part. The asynchronous part is something that happens not in the application main thread, okay? It means that I need this, I need this, I need that. Those are my requests. And when you are ready, when you send me a response, I will process it and I will do some treatment, okay? A real world analogy would be the phones. When I have a call, I am speaking in the phone and I'll tell the person I'm speaking with something, and I will stop until he answers, and so on and so forth. Another communication would be the WhatsApp, for example, or vocals, okay? Vocal messages. I will send a vocal message, and when the person receives this and is ready and available to answer me, he will answer, okay? So it's not something that happens synchronously at the same time, okay? No, it doesn't happen at the same time, and it doesn't belong to the main applications, right? This is the idea behind the asynchronous programming, okay? So that's it. This is the concept demystified. And for data streams now, what it's all about, data streams are the spine of reactive programming, okay? When you're working with reactive programming, data streams will be the spine of your application. Everything, you can create data streams from everything, okay? From messages, notifications, HTTP requests, events. And the example that they give always to explain data streams is, for example, the click events in the web, the key press events, the mouse over, and all those events, okay? The event bus in general is something that happens. I don't know when it will happen. I don't know, but I know that I should do this and that when this occurs, okay? So I will create a data stream from those events, and I will do some process later. This is the idea, okay? So in general, those are examples. And in general, it's everything that can happen or change. This is data streams. Everything that can happen or change. Not only that, but it has a side effect on my application, okay? I should be notified because I will do some treatment. I will do some process. I will take this decision. Okay, so it's anything that may change or happen over the time. I don't know when. And it has a side effect on your application. So those are data streams. And you should listen to streams to react when the value is emitted, okay? To react, when I say react, is executing some instructions in your application or taking a decision. That's it, okay? So this is your reaction to it. So you should listen to streams to be notified when something or when something changes or when the value is emitted. Another word is observe. So you observe streams in order to react later when something changes or happens. And this will lead us to the design pattern observer, which is the heart of reactive programming, okay? Also known as event subscriber or event listener. And in order to understand the design pattern observer, I will explain it through a real world analogy, okay? So imagine you have two types of objects, customer and store. And the customer is interested in a particular product, which should be available in the store very soon. For example, let's say the customer is very interested on a particular brand of smartphone, okay? So a solution would be, I don't know, maybe the customer could visit the store every day and check the product availability every time, okay, every day. But while the product is still unavailable, most of these trips would be pointless. That's obvious. Well, now another solution would be, I don't know, maybe the store could send tons of emails, which might be considered as spam, okay, to all customers. Each time a new product become available. And this would save some customers from endless trips, okay, to the store every day to check the availability of the product. But it would also upset others who aren't interested in new products or who aren't interested in this particular product. Okay, so there is conflict here, whether the customer wastes time checking the availability of the desired product, or the store wastes resources notifying the wrong customers, okay? So what you should do, you should subscribe to a newsletter and say to the store newsletter and say, I am interested in this particular product. So please notify me if this product is available. And if you subscribe to the newsletter of the store, let's say, you no longer need to go to the store to check the availability of the product. Instead, the store will send notifications to you, okay, directly to your mailbox, okay? And the store also can notify all the customers interested in this product. Or let's say here, the publisher instead of the store, because he will publish news, updates, whatever. And the customers are the subscribers. Okay, and the publisher has a list of subscribers, and the subscriber can leave also the list anytime. Okay, when he's no longer interested in the product, or he purchases the product, he can leave. I am no longer, so I will no longer receive notifications or mails about this particular product. And this is exactly the heart of the observer pattern. There are two main roles: the publisher and the subscribers. Okay, or let's say the instead of subscriber, we can say observers. There's another term, subscriber or observers, but it points out the same concept. And for publisher, we can use publisher or observable. Okay, so the publisher maintains the list of subscribers, as you can see, and he will notify all the subscribers every time there's an update. Okay, and the subscriber will perform an update. This is the behavior every time he gets a notification from the publisher. Okay, in our case, the customer will go to the store and ask for his item, and that's it. Okay, so that's in a nutshell the observer pattern. I want to demystify all the concepts to help you follow, and in the following sessions we will get deeper in details. But for now, if you understand this, it's okay for me. So this is the heart of the observer pattern. Two roles. Keep in mind there are two roles: the publisher or observable, and the subscriber, which is the observer, the person or the object that observes the changes. I said listen to or observe to. Those are the keywords in the reactive programming word, or in the reactive word in short. Yeah, and Reactive X is the implementation of the reactive programming principles. Okay, it's an API for asynchronous programming with observable streams. Okay, and the Reactive X combines the functional programming, iterative pattern, and observer pattern in order to manipulate streams and to deal with data streams. Those are the building blocks of the Reactive X API, and there is many implementations in many languages. There is RxJava for the Java world. There is RxJS for JavaScript, Rx Kotlin for Kotlin. There are many implementations, but the heart, or let's say the principles, are the same in every language. Okay, if you understand the concept, then it's easy to deal with it. It's only syntax that changes from one language to another. And today we're going to focus on RxJS, which is the reactive extension library for JavaScript. Okay, and we will go through the basics of this library, and in the following sessions we will every time split it down into pieces. I mean, every time we will speak in depth about a concept, but today we will break down into the building blocks, and we will go through the building blocks of RxJS, the concept, and the reactive principles. So the first type, which is the core type, the observables. Okay, there are core types and what we call satellite types. Okay, the core type is the observable. And when we say observable, what we mean? Okay, it's a representation of any set of values over any amount of time. Okay, it's the future. Okay, something that will happen, as I explained earlier. It's something that will happen or change over the time, and I don't know it. Okay, and so I have to extract it in a data stream. I have to represent it somewhere to stay listening, observing, to detect changes, and then react. This is what it's all about. So observable is that it's the representation of any set of future values. Okay, and when we say, again, I will come back to the event listener example. So here you can see the document.add event listener. Here we are adding click the listener on the click event. So every time the user clicks on the document, the console will trace clicked. Okay. If you are familiar with the web concepts, or this may sound familiar to you. So this is how we add event listener to the document, to any HTML element. We can add event listener for inputs, which are text fields, for buttons. Okay, so in general, every HTML element, every component that you can see in your document, in your HTML document, in the web, in your browsers, you can associate events to it. Okay, so I don't know when the user will click on it. This is something that I don't know, but I am preparing myself. Every time the user will click on it, I will do this process or that. So this is the point. And in the second screenshot is the RxJS creation of observable through the from event operator, but I will show you here a concept. In RxJS, you can create observable from anything. Anything is an observable. And you can create observable from arrays, from objects, from events, even the HTML events, okay? So yeah, so here through the from event operator, you import from RxJS, you just here put the element, the HTML element, and the type of the event, and then you have to subscribe. Okay, remember, subscribe to the newsletter. Okay, in order to get the notifications. You will not get anything if you don't subscribe. Okay, the data stream will stay open. In the memory, you have this type or this data structure allocation, memory allocation, but you will not receive anything. You should subscribe. So always remember that it's a newsletter, this newsletter example. Okay, I should subscribe in order to get notifications. And now I will show you in order to understand this. So here is Tech Blitz. I hope you see the screen. Wow. I don't know, is it clear for you? Okay, so I hope you see the screen. Sorry for the... Okay, so I will just comment all this. Those are... I was trying to put in place something. So here we will start now to play around the observables. Okay, so let's say the first thing, I will create an observable from the click events. Okay, so I should import. Okay, so I will delete all this in order to get things clear. So from event, so I will use the from event, which is available in the RxJS package. And I will say that I want to listen to the click event. So I will create here an observable, which is the data stream listening to the click event. That's it. And here I should subscribe. I have an error. Okay, so I should here subscribe to this. So here I have an observable, so this will return for me an observable. So I should subscribe to it. And when you subscribe, you can perform any kind of callback. Okay, so I will here, for example, say console.log, and I will put event click, for example. Okay, so here, I think I have something wrong. From event is not defined. I have from event. Well, don't worry, let's save. Line 3. There's nothing in line 3. From event, subscribe. Yeah. So here I don't have, this was a mistake in the compilation, but now I have nothing in the console because I didn't click on the document. Now I will click on the document and see if things are working. So you can see here, the event is clicked because I registered a callback, which says that, okay, every time the click is invoked, just do this side effect. Okay, so here is the reactive principle. I mean, here the observable, which represents the data stream, which is listening on your data stream. You need to subscribe to it in order to get notifications or to emit values. And once you subscribe on it, you can register callbacks in order to perform some kind of event, some kind of process. Here I am doing console.log. So every time you will click, you will get this. So this is the first, let's say, example. You can create even observable, as I said, from arrays. Okay, so here, I don't know, maybe I have this kind of, well, I will now just import the from, which is the operator that will create an observable from the array object, and I will subscribe to it. And every time I will say, okay, array elements. Wherever. So here I will again refresh to just avoid the compilation. So as you can see here, as soon as the page is refreshed, I have here the elements. Okay, because the from observable will emit the items one by one to the subscriber. Okay, and yeah, so this is another example. You can use also the of operator in order to create a observable of array, observable of string, any kind of object, and I will just put the same thing here, but I will just say that, well, element of array log. And as soon as it's created, it will emit values and the subscriber will subscribe for it. So this is the first, let's say, some of the ways available to create the observables. Now, there is another thing that you can do. You can create the observable by calling the new observable, as simple as that. And here, you will every time say that for every observer, I will send this value. Next, I will say here, hello, my observer, or let's say the smartphone is available. Okay, I can do many instructions. Okay, so I can send many many messages. Okay, maybe hello, whatever. So I am here just pointing out the concept, and I will just do this. So till now, okay. So let's till now I will comment this. And till now, I will not receive anything, okay? So you will not receive anything from this observable because you didn't subscribe. So you should subscribe to it. You can either do this, you can subscribe and register callbacks and say that, okay, you will say console.log. I received this message. Okay, so I will here just put the variable message I am receiving, and I will just call it like that. Okay, so here's the subscribe. Here is an extra parentheses. And as you can see now, the observer, the person or the object that's subscribed to this observable, I have only one subscription here, so one observer. So this observer has received two messages. The first one, the message, I received this message. I will just do this to make it readable. And I received this message, the smartphone is available. I received this message, hello. Okay, so I received two messages. Now, if you want to do more than one subscriber, I will just do this, cast my first observable. And this is a convention. When you are dealing with observable, you can name your variable, and at the end you put this $, okay, to say that this is an observable. So my first observable, I will subscribe to it. Okay, the first time, this is the first subscriber. I will subscribe another time. So I have here two subscribers or two observers. Okay, and here I will just copy this. I will say that I received this. I am the first, I am the second subscriber or observer, and I received this message. And you will see here, sorry. Yes. So here I will just clear the console to make it clear for you. So what happens here in the console, you have, this is the first, so the first subscriber received two messages and the second subscriber received two messages, and the observable is notifying or has notified both of the subscribers, all the observers, okay? That's it. Okay, so this is the idea. This is the idea behind it. This is how you can play with observable. You can also, I will show you something else, that you can even send an error. I mean, you can say here, I will say that the smartphone is available to the observer, and then I will notify my observer that an error happens. So let's watch here what happened. So what happened here? The first observer logged, I received this message, which is the first message, smartphone is available. But he did not receive hello. The second observable received, I am the second observable and I received this message, received the smartphone is available, and the second observer did not receive error, did not receive, sorry, hello. Why this happened? Because the observable sends the items or emit values to the observer through the next method. Okay, that's clear. Now, when we say error, it means that there's something has happened, that something wrong has happened, and the stream will be closed and will no longer emit values. Okay, so no longer values. Even with complete, it will be the same thing. Complete means that shut down. The observer is will no longer emit values for you. And but the cool part here is that the observers have different life cycles. I mean, it's not because the first one got an error that the second subscriber will get the same error. They have separate executions life cycle. It will, for the second subscriber, it will re-execute from the beginning. It will execute the complete or the error instruction, and it will complete. Okay, but the first message will be sent or emitted for both subscribers. Okay, and this will lead us to another cool part, which is the cold and hot observables. Okay, sorry, so the cold and hot observables. For cold observables, the data is produced by the observable itself. For the hot, the data is produced outside the observable. Here, the first case is the observable I created with the new observable, and I was emitting values, hello, the smartphone is available. This is the cold observable, okay? Data are produced by the observable itself and immediately. For the click listener, I wrote it at the beginning, the data is produced outside the observable. It's not the same thing. This is the first difference. The second difference, for the cold observables, it begins to emit items only after the observer subscribed to it. The second one, which is the hot, may begin emitting items as soon as it's created. Okay. And the third difference is each observer or subscriber gets its own unique set of items. But for hot observable, the emitted items are shared between all the subscribers. The same item is shared, and that's what we call multicasting. And I will explain this for you by example. As I said, this is the cold, okay? My cold observable, this is the cold observable. Well, and this is the hot one. Let's say. So this is the hot, my hot observable. The dollar, but for it's the best practice, okay? And here I will just subscribe to it. My hot observable.subscribe. Well, let's go. Okay, so now for the cold observable, I will explain the part of multicasting and emitting different values. Here, the value is static. But suppose the value is dynamic. I don't know, maybe we can math at random, for example. Okay. So here I will not complete. I will send math.random. So this is my called observable. It will emit value after subscribing. So this is the first subscriber. The first subscriber will, I will say here, first observer. And here, second observer. I received this message, okay? And you will see, yeah, I received this message, which is this random value number, and here is a different number, okay? And we already noticed this, okay, because earlier when I put error and the message hello was not emitted for the first observer, but the second one received the first message and then did not receive hello. So there are two separate executions. And here you can, while there are two different executions, so if there is a dynamic treatment, every observer will get a value. Okay, it's not the same value. But however, for the hot, this is for the cold observable. For the hot observable, it will not be the same case. So here, if I will register another one, okay, I will create another subscription or another observer or another subscriber. I want you to get familiar with those words, and I will say .log. I don't know. Okay, so here, as it's a hot observable, so it should be I earn time. So here when I click, so event clicked. So you have here for all the subscribers the same values. Okay, if I put, yeah, so every values are the same every time for all the subscribers. And when you put a dynamic treatment is maybe a different, but this is the idea about it. Okay, so here I should zoom a little bit, I think. Yeah. I'm sorry, I'm not listening to the comments in the YouTube. I'm not seeing, sorry, the comments in YouTube. I have only one monitor. And yeah, so here I hope it's clear now. But as you can see, I will delete all this. Useless code. Up. So I can repeat if you want, as it was not clear. So here you have the cold observable, you have the observer, you send messages to this observer, which is math.random, which is a dynamic value, let's say in this example. And here you have two subscriptions. This is the first one, this is the second one, okay? And for every subscription, you have a different value of this. Yeah, as you can see here, here's the value, here's a different value, okay? For cold, this is the cold observable. Okay, the values are, can be different, okay? Here is the other thing, here is the hot observable. And for hot observables, always it's the same, the value, when the value is here I have the click event, okay? I will propagate this click event. I have this value, I am listening, I listen to, there's a click, the user did a click, here I am clicking, okay? I am clicking on the document. I will broadcast the same value, and this is what we call multicast. I will broadcast the same value, and yeah, as I'm listening to something, yeah, I heard this. and I will broadcast to all the subscribers. For the cold observable, it's not the same time, the same thing. You can use it for a different value, and this is what it's all about. I mean, here it's what we when they call. So each observer gets its own unique set of items. For the hot observable, the click events, all the events, and the similar types of observables are shared between the subscriber, which is the multicast. So when we say multicast, the emitted items are shared between the subscribers. Okay. The second now, let's move to the observers. And I think it's because we explained it when we were talking about the observable. It's the second satellite type, okay, the observer. And the observer is the object that observes. It's the subscribers, okay? It's the consumer of values delivered by an observable, and it's the consumer here. There's the same thing, is also the set of callbacks. When you see this, it means that for each type of notification delivered by the observable, which is whether a message or error or completion, okay, the observer will register callbacks for it, okay? And there are three types of notifications, whether with the next, here the observer will get a next value. With the error, the observer is getting an error. With the complete, it's the complete and no stream notification, okay? And here, again, I will come back here. I can register callbacks for every scenario, okay? So here, for example, let's say the observable, this is my called observer, sent a message for the observer, okay? So I will register callback that will react. This is the side effect when a message is received. This is my callback, okay? It's a plain function. For every message received, I will just log first observer, I received this message, okay? But I can register up to 3 callbacks, and they are partial. I mean, you can register 1 callback, 2 callbacks, or all the callbacks, okay? You are not obliged to register all the callbacks. For this case, I will add the error callback. To add it, just another function, which is the error, okay? And here I will say that when you receive an error, do this, okay? This is what we call the event-based programming. I will do this when this event comes, or when this event occurs, perform this. When this event occurs, perform another treatment, and so on and so forth. So this is the event-based programming also. So here, when an error occurs, I will just log error comes. And when the observer is shut down or completed, I will say that console.logby, for example. Okay, sorry. So here, the first one, the first callback, I will do a side effect when a message is received. In my case here, I am just logging in the console. I will log in the console a different message. I will log, sorry, in the console a different message when an error occurs or when the observer completes, okay? So here, I will just refresh. Okay, so you can see the error comes and the bye. And it's normal because there is no error and no completion. But I can, simulate it. I will do this. This is while I am constructing my observable. I am here telling that, okay, I will send to all my observable this message. And after that, I will send an error, okay? an error happens. Okay. And again, I will refresh it, and you will see my observables received a message, and then an error comes. So the callback, so my callback as an observable get executed. Okay, so this is what I was trying to explain. It's something event-based, okay? What I will do or execute when an error happens, what I will do or execute when an event occurs in general, okay? And yeah, this is the power, I mean, of the event-based programming and of reactive programming in general. I am reactive, I'm not proactive. I react when something happens, and this will save me resources, will save me time, and will enhance my performance. Okay, so this is the idea, and when it completes, we can say the bye. Okay, this side effect was not executed. Again, side effect or callback. So it's the same thing. Okay, so this side effect was not executed because the observable is not completed. Still, the stream is still open. Now I will say that I will complete it, and I will just do this. Tack. No longer observable, and you can see here the bag. Okay, I will refresh it to, yeah, so you can see those are two executions. The first, I will explain what you can see here. So here, the first subscriber, the first observer, has a registered callback for completion. So when the observable completes, this callback will get executed, so you can see this back. The second one will just log, I received this message. And when the completion occurs, nothing happens because there is no callback registered in the second one. There is no callback here, as you can see. Here I have only one callback, which will be executed when a message is received. The first one, when a message is received, the second one for errors, and the third one when the observable is completed. So as simple as that. So that's it. I mean, it's very simple. Here, I don't have a callback, I do nothing. Okay, but it's highly advisable and recommended to register callbacks when you need to. Okay, when this event is important in your application. Here, I am just doing errors, completion, etc. But in the real world examples, you may have many complex scenarios, so or use cases, and you have to be careful when to register the callbacks and how. Okay. Yeah, so I still have 10 minutes. So here is the observer, I mean the second satellite type. The third satellite type is subjects, and it will be deeply explained also in the following session, in the following session. I think, I don't know, maybe next month or the month after. But subjects are the third satellite type, and it's an observer and observable at the same time. Okay, so it implements the observer interface, so you can do subject.next, subject.error, subject.complete. It can behave as an observable in itself, and at the same time you can multicast many values when using subjects. Okay, you can multicast, or they are considered as multicast observable, and plain observable are unit cast. Okay, you only operate with the subscription in itself. You don't multicast values to all your observers. Yeah, and the third satellite, I mean the fourth satellite type, is the operators, and operators is the most fun part of RxJS. Again, there is a session explaining operators, but today it's kind of the big picture, the reactive mindset, the reactive programming principle, and later on we will explain it deeply. We'll explain the other concepts in depth. And the operators here, in short, are they are pure functions, okay, and they are inspired from JavaScript arrays. If you're familiar with JavaScript arrays, you can be familiar with methods like map, filter, reduce, every, etc. And yeah, they are very helpful and comes in handy in the functional programming. And when you want to manipulate an array or transform an array or just filter an array, okay, and search an element inside an array. There are many use cases in arrays that the operators, the array methods comes in handy to allow handling this, the instructions and operations inside an array. Same thing here for operators in JavaScript. Operators help manipulating the data streams, the asynchronous data streams, the asynchronous events, the asynchronous collections, objects, all of that. Okay, so you can, with operators, you can manipulate those streams. Okay, so, okay, we now learned how to listen, how to subscribe, how to register callbacks. But if I want to manipulate the streams, the income scheme, what should I do? You should use operators, okay, to transform, combine, manipulate, and work with sequence of emitted items. As I said, there are pure functions which takes as input an observable and generates another observable as output, which will be transformed. Okay, the initial observable, but with some transformations. And you can create, there are a set of, many operators in RxJS. And you have many operators even by category. For transformation, you have a set of operators for combination, merging, many things that you can say. You can find many operators in RxJS, and you can also create your custom operator if you want to. Okay, and customizing operators also is very important. And the last type is the schedulers, and the schedulers are are like observable and subjects, but lets you define in what execution context will an observable deliver notifications to its observer. Okay, you can delay the execution and control the time. Okay, so a scheduler is an execution context. It denotes where and when the task is executed, and it has also a virtual clock. Okay, it provides a notion of time. You can just call now in order to get the time, and you can schedule tasks according to the scheduler. Okay, you can do some processes, okay, using the schedulers, and benefit from the all the reactive and features, okay, of the observables by using it. Yeah, so this is the last type, which is the last satellite types. And here are my takeaways, okay, today. Those are the building blocks of RxJS, the building blocks, the fundamentals, main principles, what you want. That what you should here take away with you, and you will, as I said, we will explain it in depth in the next sessions. But yeah, we will play with all the concept. With the observable, it's a set of future values or events. Observer are callbacks that know how to listen to values. They listen to values, they consume the value, and they react to this value by registering callbacks. Subscription is the execution of an observable. An observable starts to emit values when we subscribe to it. When there's no subscription, there's no values, okay, in short. And operators are proof functions that enable manipulating observables. Subjects are observer and observable at the same time. Some people see it as the equivalent to an event emitter. Okay, and it's the only way of multicasting a value or event to multiple observers. Schedulers are centralized dispatchers to control concurrency and to scheduler some processes in the reactive world. That's it. Hope it was clear and hope it was it was clear and you understand those principles. Here is a good resource. In the official documentation, you can find the section resources and you can find many helpful sites. Learn RxJS is very good with some examples, the official documentation, some YouTube videos. You can see many good resources there, so check this out. And thank you very much and stay safe. Don't hesitate if you have any questions. So yeah, don't hesitate to reach out and to ask. Yeah, and again, hope it was clear and it was helpful for you, and stay safe. Thank you.